In the past, we looked at how a current carrying loop can create a magnetic field in and around the loop. But we didn't analyze how the loop itself would be affected by its own magnetic field. First of all, let's use the right-hand corkscrew rule to figure out what the magnetic field would be like in and around this loop. You have to grab the loop with your right hand. The fingers here, in this case, they would curl in such a way that the field would be coming out of the loop in the center. So there would be dots inside the loop and X's outside the loop. That's just a review from the past. But what's new is that this part of the loop will actually feel a field due to the other side of the loop. It would be a dot. And if we do the right-hand rule on a different section of the wire, once again, the fingers are coming out of the page. And so not only would there be dots in the middle of the loop itself, but there would also be dots on the other side of the loop. No matter where we hold the loop, this is going to be true. That there will be a magnetic field pointed out of the page at all points around this loop. And there would be X's outside of it. So the first step is figuring out what kind of magnetic field exists at the positions of the loop itself. And then we want to go to the next step, which is using the right-hand cross product rule to figure out what the forces on this loop would be. So at this position here, let's point our pointer finger in the direction of current, which is to the left. Our middle finger should point up out of the page. There would be some other fingers as well. And then our thumb tells us the direction of the force on this part of the wire. Notice though that the thumb is pointing up. So the force on this part of the wire is up. We can do the same analysis here. Pointer finger points in the direction of current. Middle finger points out of the page. That's the B field direction. And our thumb points to the left. So the force is to the left on this part of the wire. The same pattern will continue, and we'll find that at all points in this loop, the force is directed outward. So the magnetic force on this current carrying loop is directed radially outward. It makes the loop want to expand or explode.